Hi all, welcome to Shaper's Learning Academy, Deep Learning Module 4. In Module 3, we studied in depth about the activation function. A small recap, activation function is the function which triggers a neuron to give an output. Let's understand various other deeper concepts in this module. Forward pass and epoch. Each data point from the dataset is used for training and is passed through the network. So why a data point needs to actually get traversed through the network? Because it is a training dataset which gives us the actual education or the actual learning for the neural network. This pass through the network from input to output is called as a forward pass. And the resulting output depends on the weights at each connection inside the network. So a training dataset passing through each and every layer of a network is called as a forward pass, and obviously the output depends upon the weights input as well as certain word called as bias, which we'll be studying in the further slides. Once all of the data points in our dataset have been passed through the network, we say that an epoch is complete. So epoch refers to one single pass of the entire dataset through the network during training. So we have something called as a training set, which will make the network learn, and the passage of one training set through all the layers until the point of output is called as an epoch, and we say that epoch has been complete. Bias of a network function. The activation function in neural network takes an input x multiplied by weight w, as we know. So we have an input. This input is being multiplied by the weight w. So the output is a function of w0 star x, as we know. So there is one more element called as bias, something like this, b. Bias allows you to shift the activation function by adding a constant to the input. As we know, the neural network is a concept of optimization, and for optimization to happen successfully, a function, an activation function, will need to have an element called as bias. Bias helps in controlling the value at which the activation function will trigger. Very obvious, right? Activation function is the actual function which determines the output, or which determines when the neuron has to trigger, and bias is an element which helps in controlling the trigger. So this is an example for a function without a bias, this with bias. So here we have three inputs, x1, x2, x3, with weights w1, w2, w3, and this being the neuron. So the function z, the output is the product of x1 into w1, x2 into w2, x3 into w3, plus the weight, or plus the bias. Bias as a single neuron. This simple neural network consists of three types of neurons. One is the input neuron. So this is the network that we are speaking about. This one input neuron simply passes a future x1 from the dataset. Bias neuron, which is usually a value 1. Bias neuron mimics the additional feature called as x0. Consider this to be x0. The additional input is always equal to 1, yes. Finally, there is an output neuron, which is a full-fledged artificial neuron that takes the inputs, processes them, generates the output for the whole network. So to give a better clarity, this is a neuron, this is the weight w1, this is a bias. Hence, the output function or the activation function becomes y is equals to x1 into w1. x1 multiplied by w1, obviously, input multiplied by the weights, plus the bias. Now, let's understand what happens when there's a neuron without a bias. It is necessary to move the entire activation function to the left or right to generate the required output values, and this is made possible by bias. This is a plot of a function, yes. Now, the activation function either a tanh function or a sigmoid function or a linear function cannot be made to stay in the origin. It has to move to the left or the right of the quadrants in order to produce an effective activation function. So it is necessary to move the entire activation function to the left or right to generate the required output values, and this is made possible by bias. And this is a function without a bias. This is something with a bias. To gain more flexibility, we need to get back to the original model with the bias. It helps us to create, it will equip us with weight W0 not tied to any input. So this is the case over here. These are some of the interesting terms we are supposed to learn in a deep learning course. What is a training set? Training set is a set of inputs. A training set is a group of sample inputs you can feed into the neural network in order to train the model. The neural network learns from your inputs and finds weights for the neurons that can result in an accurate prediction. The neural network trainer, the neural network designer who trains the network, has to be a responsible personality in feeding the right data. So only when you feed responsible right data, your prediction and the output and the further operations of a neural network will be right. What is the training error? The error is the difference between the known correct output from the inputs and the actual output of the neural network. During the course of training, the training error is reduced until the model produces an accurate prediction for the training set. Simple. Training error is the expected versus actual output. What is a validation set? A validation set is another group of sample inputs which were not included in training and preferably are different from the samples of the training set. So once you finish training the neural network, you are supposed to validate the neural network by using a validation set. Once you obtain the right values or right predictions from the validation set, you can assure that the network is perfect. What is validation error? The difference between known correct prediction and the validation set is called as a validation error. Bias, variance, and two other important terms called as overfitting and underfitting. What is a bias? A high bias means the model is not fitting well into the training set. This means the training error will be large. A low bias means the model is fitting well and training error will be low. A high bias means the neural network which has been designed is not apt. The training set is a set which we use for training the network, and if the training set is not fitting well into the model, that we call as a high bias. Whereas a low bias means the model is fitting well and the training error will be low. Still it's a bias. What is variance? High variance means the model is not able to make accurate predictions on the validation set. The validation error will be large. The word variance. High variance means that the model is not able to make accurate predictions in the validation set. As we know, validation set is supposed to be testing set. So you train the network with a training set, and once the training is done, you validate using validation set. So when this high variance means the model is not able to make accurate predictions on the validation set. The validation error will be large, yes, obviously. Low variance means the model is successful in breaking out its training data and making right predictions with the validation set. Let's understand overfitting and underfitting. Giving an example, as we know, neural network is learning by training with training data set. Just imagine a student is being educated in English and is being fed only with Shakespeare plays. So on the course of time, the student becomes specialized in Shakespearean type of English, whereas he may not be able to generalize the subject. So the overfitting concept is something like this. Overfitting is trying to learn the English language by using a very specific training set. For example, reading all the plays by Shakespeare, as I said. Someone who learns a language using only Shakespeare as an example will learn a very specialized form of English and may not be able to understand the other English text. Overfitting happens where the neural network is very good at learning its training set but cannot generalize beyond the training set. So what are the characteristics of overfitting? Usually low bias and high variance. What is low bias? Accurate predictions of the data set. Low bias. High variance, poor ability to generate predictions for the validation set. What is underfitting? A model is said to be underfitting when it's not even able to classify the data it was trained on, let alone data it hasn't been before, characterized by high bias and high variance. Underfitting is a weaker network where the model is not able to classify or predict the values as per the training set also. Underfitting is usually characterized by high bias and high variance. Loss function is another important functionality in deep learning, and we are going to study about the loss function in detail in the subsequent videos. Here we are going to have certain basic understanding of what you mean by a loss function. A loss function in machine learning is a measure of how accurately your ML model is able to predict the expected outcome, which is the ground truth. A high value for the loss means a model performed very poorly. A low value for the loss means a model performed very well. So let's stop with understanding of the loss function over here, whereas in the subsequent videos we'll have a detailed explanation of loss function and its calculations. Thank you for your time, for your understanding, for your patience, and kindly help me with improvements, suggestions for improvements of the videos and the content.